Okay, so this is reacting masses with no limiting reagent using dimensional analysis. Let's take a look. We're starting out with 54 grams of calcium carbonate, and we're trying to find the mass of calcium oxide. For dimensional analysis, the basic steps that we're going to be doing is our grams of our reactant to moles of our reactant. We're going to use the molar ratio from the chemical equation to moles of product to grams of product. So let's take a look and see what that looks like. So we're going to start out with grams of reactant, 54 grams of calcium carbonate. You need to make sure you keep track of what your chemicals are. So make sure you're not just writing grams, make sure you're writing grams of calcium carbonate. Now, to go from grams to moles, this step right here, what we need to do is we need to figure out how many grams there are for every 1 mole of calcium carbonate. And we can do that by looking at the periodic table. It's 100 grams for every mole. So we did that first step. The second step is we're going to use the molar ratio between the moles of reactants and the moles of products. According to this reaction, it's a 1-to-1 ratio. So for every 1 mole of calcium carbonate, we have 1 mole of calcium oxide. Great. We did our ratio, our moles of reactant to our moles of product. The final step that we have to do is go from moles of product to grams of product. And again, we can take a look at the periodic table for this. Calcium has a molar mass of 40, oxygen has a molar mass of 16. So we know that there's 56 grams of calcium oxide for every 1 mole of calcium oxide. Okay, and then in my calculator, what I would type would be 54 times 1 times 1 times 56 divided by 100 divided by 1 divided by 1. So when I do that, 54, I get 30.24 grams of CaO. Okay. Some things to note here. These are just the molar masses, and this is the ratio. So if you're trying to go from grams to grams, it goes grams, then molar mass, then ratio, then molar mass.